Well, thank you very much. I'm really very honored to be here to give the Keeling lecture. And I guess I kind of believe that a picture is worth 1,000 words. And so I'm hoping to take you through a veritable encyclopedia in the next 45 minutes. I titled this lecture, Avoiding the Unmanageable, which means reducing greenhouse gas emissions enough so we don't get into dangerous territory or hit tipping points, and managing the unavoidable, or coping with those changes that are already happening, and there are more in store. And I would say we're not doing a great job at either right now, but we especially need to devote a lot more interdisciplinary attention to the coping with climate change and understanding really how we can adapt to the changes that are ongoing. So it's a great pleasure to talk about David Keeling, who is truly an icon. I had the honor of being with Al Gore in 1997 when he presented Dave with a certificate of recognition. And I have his remarks still, and so I will quote some of them to you. He said, "The Keeling curve is the most important single piece of evidence of the human effect on global climate and the entire Earth system. Roger Revelle, your colleague and my mentor, had already referred to your measurements as the, quote, smoking gun of the greenhouse effect as early as the 1960s. I can tell you that President Clinton and I have made the story of the Keeling curve required reading for all senior officials in the government working on climate issues. We owe you all a debt of gratitude," end of quote. And yes, everyone had to know about the Keeling curve. And it's really exciting that this principled science of David Keeling is still in the news. And this is from your own San Diego Union Tribune last year. We need more principled science, I would argue. I am actually the proud possessor of a hunk of pumice from Mauna Loa that was given to me by John Chin, who worked on making those measurements with and for Dave for 36 years. So I wrote to him and said, tell me a little bit more about this. And he wrote to me that, of course, Dave was a very careful scientist. He required Chin to use number 3 hard pencils to take all the data, and that he had to draw sharp parallel lines on graph paper of the reference gas trace and then the sample gas trace, and measure the distance on the graph paper between the two. And then the originals had to be sent here to UCSD, and that left poor John Chin with a light carbon copy of that number 3 pencil, because of course there were no copying machines then. But Chin said that Dave was a great man and treated him like a son. And then in 2001, of course, Dave received the Medal of Science. And that was actually something that Gore had nominated him for while we were still in the White House. But it takes several years to get that through the system. And so it was 2001, and somewhat ironically, George W. Bush put that medal around Dave's neck. And Louise has a great story about her incredulity at receiving the phone call to say he was getting the Medal of Science. And then last but not least, of course, in 2005, Dave received the Tyler Prize for Environmental Achievement, which is really the closest thing we have to a Nobel Prize. So it was quite amazing. Well, here is that curve, that amazing crown jewel of climate science. It was 310 parts per million of carbon dioxide when Dave started measuring it, and on May 4th, it hit 410. It is inexorably climbing. And the words of the 6th century Chinese philosopher are as true today as they were then. If you don't change direction, you're going to end up where you're heading. And where are we heading? We are heading to the roasted world that you see on the right of this chart if we don't change direction. And I really see this century as a tale of two worlds, two future worlds that we can leave the next generation. Over the lifetime of our children and our grandchildren, decisions on which of those two worlds we have will be made. And the only things that we can do to cope with this are to mitigate or reduce emissions, greenhouse gas emissions, to adapt or cope with changes already underway and those that are coming, or to suffer. And we are suffering. We are actually experiencing the impacts now, and I'll show you some of those. But The good news is that the world came together in Paris at the end of 2015 and decided to do something about it. And 194 countries are trying to do so, and I'll talk about that later. So what I want to do is talk about climate change in 5 segments. 1, that it's all about equity. Then 2, review some of the evidence that we know it's human and that it's happening, the impacts we've already seen, the impacts that might come, and wither the climate agreement, although I hope the H is in there, the first H, and that the climate agreement is not going to wither. So it's all about equity. This is a picture, well, there's 3 ways we can think about climate change and greenhouse gases. One is to think about all that's been accumulated, and so maybe think of it like as the bathtub of greenhouse gases since they've been emitted, and a lot of these gases last for a long time. So if you think of it as that, then the circles on the left are showing you the cumulative emissions in that bathtub, 64% from the high-income countries and 36% from the low-income countries. And if you think about people over all that time, this is the hatched part of the atmosphere that the rich countries have overused. And then, if you think about the 1.2 billion poorest people on the planet, their contribution to the bathtub is that teeny weeny yellow sliver that just showed up. Whereas on the right, you can see that the impacts will be 80% focused on the poorest countries of the world. So you begin to see the equity issues are rife as we try to combat climate change. And in part, the reason for the impacts being so prevalent on developing countries are because of agriculture. So this is an analysis I did for the World Bank. It's a composite of 13 different crops, and it's showing you where they will increase in green, where they will decrease in red, and the reddest reds are a loss of about 55% productivity. So you can see which countries stand to win and which countries stand to lose. So if you think about this as a cumulative impact, the rich have imposed this on the poor. Now you can also think of, okay, so the bathtub is full, but there's what's coming in now? What's the flow into that bathtub? Well, here are the top 10 countries that are emitting into the bathtub. China finally has exceeded us. But you can see if you look at these top 10 countries, why the countries in South America and Africa and the small island states are so vocal at the Paris negotiations about wanting to get help with climate change and to have these folks drop emissions quickly. A third way you can think about equity is to look at per capita emissions. Unfortunately, we're the big winners here, or the losers, emitting more than 16 tons per person. But you can see that China, I had to raise this bar because when I actually got it for the first time, it was much lower. But China's still coming in at about 8, or half of where we are. India, much lower than that. And then if you look at these dotted lines, which are the middle income average and the low income average, look at all these countries that are way, way, way below 1 ton per person. So equity, very important, many ways to think about it. Very hard, though, to deny that the poor countries are at greatest risk. So let's move into a bit of how we know what we know, that climate is changing and due to human influence. You know, some of my students ask me how old the theory of climate change was, and I go, well, it's pretty old. And they go, like before I was born, like 1988? Well, actually, no, like at least 100 years earlier. One of the seminal papers here by Arrhenius in 1898 concluded that if you add carbon dioxide, a gas that traps heat, and you're burning carbon-based fuels, coal, oil, gas, and wood, that's going to increase the temperature of the planet. And surprisingly, his calculations, I don't know if they were made with the number 3 pencil, have been remarkably stable over time. So how do we know what we know? Well, we can decipher past climate. We have many, many tools, and we can decipher climate from hundreds to thousands to millions of years ago, looking at growth rates in tree rings, the concentration of gases in ice core, the kinds of pollen and fossils in rock, and coral growth rates. But now we can have many more sophisticated ways to show that climate is changing currently, and that really complements our Keeling measurements. We literally make millions of measurements of temperature and precipitation, sea surface height, regional changes in ecosystems. We can measure from the top down with satellites. We can go vertically up through the troposphere and the stratosphere with balloons. We measure temperatures down to 10,000 feet in the ocean column. And so with that increasing evidence, the science has gotten very much stronger over the last 20 years. And to save you reading these enormous tomes that come out every 5 years from the scientific literature, I'm going to just show you some of the summary statements. But if you had looked at the Intergovernmental Panel on Climate Change, which is a group formed by the United Nations and the World Meteorological Organization, in 1995, in what they thought was a remarkably declarative sentence, they said, we see a discernible human influence on the climate. And what they meant is they were seeing a fingerprint of humans in the record. But by 2001 and then 2007, they had gotten much clearer evidence, so that in 2001 they said most of the warming in the last 50 years is due to anthropogenic or human influence. And then you see in 2007 they assigned 90% probability to this, and then this is the most recent one, that said 95% probability. And you know, when you think about the things that we're willing to buy insurance for, you don't probably bet against something that's 95% certain. I looked up this afternoon the probability of you being killed in a car crash here in California, and it's 1 in 13,000, but I'll bet most of us have insurance against these kind of things. We do understand now that the growth of CO2 in the atmosphere is correlated with the growth in fossil fuel use. And you know, despite all the discussions that we have about renewables and nuclear, most of the world is still very much carbon-based. So biomass, coal, oil, gas, and you see these tiny slivers of hydropower, nuclear, and on this particular chart, you can't even see the other renewables. And from 1950, about the time that David was starting his measurements, to today, energy has increased about fourfold, and it could easily triple again by 2100. So we're now putting 9 billion tons of carbon dioxide into the atmosphere each year, mostly from the combustion of fossil fuels. There's another percentage from deforestation, and there are other greenhouse gases too, but you really can't confront and tackle climate change without confronting carbon dioxide. And so keep that curve in mind. And here we can see that the temperatures are rising too. So this is the CO2 trail, and the bars are the temperature trend. And you can see that it was probably 280 parts per million, but by the time that David started measuring them, it already was at 310. And this was 2015, so we were at 400, and I had to put a little star on here because 2016 beat it both in temperature and in carbon dioxide. So despite bumps and wiggles in the record, which are due to things like solar cycles and El Niños and volcanic eruptions, you can see what the IPCC, the Intergovernmental Panel on Climate Change, was saying. Most of the warming appears to have happened in the last 30 years. And in fact, you can't explain this temperature record without man-made heat trapping. So the emerging evidence is at this about 1 degree Celsius or almost 2 degrees Fahrenheit temperature increase that we've seen, that we're already starting to see negative impacts. And so if we get to 2 degrees C or about 4 degrees Fahrenheit above those pre-industrial levels to that roasted world I showed you, we will have probably 20 to 30% of the species at risk. Another billion people will be exposed to water risk. We'll have a complete loss of tropical glaciers, and water supply for major cities depends on tropical glaciers. We'll have a loss of coral reefs, coastal inundation from sea level rise, and so a lot at stake. So let me show you, this is on the right, you see 3 million metric tons, and here is the year. And I just think it's really interesting to kind of watch how emissions developed and where, and how quickly they develop in some parts of the world. And when this is done in about 20 seconds, you'll also see where there are no emissions. And the parts of the world that I mentioned earlier are questioning where the equitable arrangement is on all of this is. So now we're at 1920, and you can see the eastern US at least lighting up, and some of the west. Now we're getting into the territory where Dave Keeling's measurements are starting, and you can start to see what's happening in Asia. South Africa is lighting up. Europe is lighting up. And so we started at 2, and we went from 2 million to almost 9 billion metric tons in that time. So again, here's that same temperature record that I was showing you, but here I do have 2016 as the warmest year on record, and each of these blue bars is showing you the decadal average. And so for those of you who heard in the news, maybe there was a hiatus or not warming, you can see that each decade has actually been warmer than the previous decade. And so it was 16 of the last 17 years have been the warmest on record. The rate of CO2 growth over the last decade, so the last decade, is 100 to 200 times faster than what the Earth experienced when we were popping out of an ice age. And so this is a transition that has not been experienced before. It's the rate of pushing the Earth and the ecosystems and people and infrastructure that's as big a problem as the magnitude. So both rate and magnitude are very important. And this is showing you kind of the same thing in how temperature. So there's always hot and cold spots on the planet. But again, as we start to get into the 50s and the 60s and the 70s, you can start to see the redder reds, the amplification of warming in the Arctic for sure. And around 1970, here we go into the 80s, you can see how dramatically things are warming. All right. So if you put this on the very long-term time record, and when I said we have ice cores that actually go back about 1 million years, here I'm only showing you back 400,000 years, but you can see that carbon dioxide went up and down between 180 and 280, and then here we have David starting measurements for us. And here we are suddenly in May of 2017 at 410 parts per million. That's that great acceleration, that 100 or 200 times. And so this is clearly outside the range of anything the Earth has seen probably for millions of years. Okay, so I'm going to spare you reading the thousands of pages that the Intergovernmental Panel on Climate Change produces every 5 years and just simplify it and say there are 10 things that if the theory of climate change is right, we expect to be happening, 10 signs. 5 of these are temperature that should be going up. So that's sea surface temperature, deep water temperature, temperature over land, temperature over sea, air temperature. 2 others that should be going up are increase in sea level and humidity. So when you crank up the temperature, you speed up the water cycle, you get more water in the atmosphere, more can come down as rain, or it can come down as snow. So snow does not mean climate is not changing. But the 3 that are going down are all related to ice and snow, glaciers, snow cover, and sea ice. All 10 of these expected indicators of climate change due to humans are happening. And here's the real data behind them. I'm showing them to you to just say there are multiple lines of evidence for each of these and many decades, if not centuries, of information. So here are the 5 temperature ones we expected to be going up. Here's humidity and sea level. And of course, sea level is partly because you're warming the ocean and it takes more room when it expands, but also because land-based ice is contributing to it. And then here are the 3 that are going down, all related to ice and snow. So I'm sure you've seen some of these trends before. Mountain glaciers all over the world are receding. This just happens to be one that I very painfully climbed, Grinnell Glacier in Glacier National Park. And it's really quite a difference. The exposed darker Earth is absorbing more heat than the reflective area, and we may soon have to rename Glacier National Park because there's only 26 left. There used to be 150, so we might need a new name. But as I mentioned earlier, there are whole cities that depend on glacial melt for water, so the loss of glaciers can be extremely significant. And Greenland, I'm sure you've heard about. Greenland is land-based ice, so when it goes, it does raise sea level. And we're seeing a very rapid melt of the Greenland ice sheet. In fact, our ice models didn't predict this. So you can see the areas that were melting in red in 92, in 95, in 2005, 2000, and then briefly in 2012, the entire surface of Greenland was melting. So this Greenland melting and parts of Antarctica melting have actually suggested that sea level rise is going to be quite a bit more than we thought. And NOAA, the National Oceanic Atmospheric Administration, says, you know, it could be up to 2 meters by the end of the century, which is a lot more than we used to think. But we do know that the rate of sea level rise has roughly doubled since the 1970s. Now, if all of Greenland were to go, which is not going to happen in our lifetime or your children's lifetime, that's another 21 feet or 7 meters of sea level rise. And I'm sure you've heard a lot about the Arctic. That's floating ice, so when it melts, it doesn't increase sea level. But again, it's a dark area when it melts, and so you really absorb a lot more heat, and you get an amplification of the warming. But we're expecting we could have an ice-free Arctic in the summer pretty soon, certainly by 2030, and all kinds of interesting issues of who owns the seafloor and passage of vessels are coming to the surface. But this is what it looked like, the minimum in 1980. Here's what the minimum in the summer looked like in 2012, and that's the loss of a size of India, for example. We won't know till late September what this year's minimum is, but here's the record so far for this year. So the blue line is 2017, and we're kind of below this dotted line, which was the lowest before 2012. So we'll see what's happening, but definitely the sea ice is disappearing, and both the Northeast and the Northwest Passage have been open in recent years. Okay, so we're having all these physical changes. We have the 7 arrows going up and the 3 down, but so what? Well, the physical changes are causing impacts that are already being felt by society. As I said, it's speeding up the water cycle, it's increasing precipitation, it's raising sea level, and those 3 things alter the ideal range where forest crops and pests can live, the timing, quality, and quantity of water, and all those things are happening simultaneously. We do have independent proof that those physical changes are changing ecology. So we know that spring is coming 1 to 2 weeks earlier. We have evidence from 75 botanical gardens around the world and satellite measurements. And in fact, when that data came out, we used that information in the White House when Margaret was there to change the date of the Cherry Blossom Festival in DC, because every year the cherry blossoms were blooming earlier and earlier, and then we'd all march around and they'd all fallen off already. But we used that as a teachable moment when that paper came out about the reference gardens. We're also seeing that the ideal range to grow crops is shifting in response to changing temperature and precipitation. Extreme heat and records are being broken all around the globe, and there were record temperatures in the last 2 years in Southern Europe, in India, in Russia, and Japan. We're seeing drought, and that's because you're warming things up and evaporating things faster. You not only get total water increase, but you also get drought in some places, especially in the interior of continents. And it's cost the US about $6 billion a year for drought. But you know, in 2015, your California drought cost over $2.8 billion. So these things can really add up to a lot of money. And we've seen food crises in many parts of the world in recent years, and that really shows us how fragile our food distribution systems are. Now this year, the spring is so wet in most of the Midwest that farmers are planting really late, and now we're worried they won't get their crops out before the frost. But we're also seeing pests increase. So warmer, wetter weather is helping all sorts of pesky invasives, ranging from mosquitoes to ants to ticks to molds to avian flu to West Nile virus. increase their range. And many of these are no longer held in check by frost lines in the north or moisture lines in the west, where kudzu was, for example. So we're seeing kudzu everywhere. So a warmer world is really a peskier world. The ragweed season in the Midwest is already 2 weeks longer now. And the compound in poison ivy that so many of us are allergic to, urushiol, is becoming more potent as the poison ivy plants grow better. So warmer, wetter world, not necessarily green in a good way. But all in all, we now have 25,000 data sets, each more than a decade long, showing that physical and ecological impacts are occurring in concert with expected changing climate. Okay, well, so what? Earlier springs? Well, think about it. Different animals and plants are signaled by different cues, by light cues, some by temperature cues, and we're beginning to get asynchrony in when birds hatch and when their food supply appears. I mean, this one's a teeny bit tongue-in-cheek. This is a Yellowstone weasel. And in April in Yellowstone, you're still supposed to have snow. So that's why he's wearing winter white. Clearly not camouflaged, and the snow is all gone. So this poor guy is probably going to be eaten. But, more importantly, things like the increase in heat are definitely affecting people. So this is a map on the right of the fatalities in 2003 in Europe, which you will all agree is a wealthy part of the world. That heat wave killed at least 35,000, and with the residuals, we think it actually was up to 70,000 in a rich part of the world where they have air conditioning. And in the last few years, we saw incredible temperatures set. And then you see in the bar charts, Pakistan 128, Sudan 121, Bolivia 116, Russia 114, and even Finland at 100 degrees. And this past year in Iran, the heat index, which is a composite of both temperature and humidity, reached 163. I mean, this is devastating, dangerous to humans and to livestock who can be out in that kind of weather. So amazingly, we're actually reaching physiological limits for human and livestock. And we're seeing drought-prone regions get more droughty. This chart suggests that maybe that incredible drought you have just experienced may not be anything yet. Here's what we project for drought in the West going forward. You all know that last year at this time, Lake Mead had shrunk to its lowest level. It was down to 37% of capacity. And as of May 4th this year, it looks like Lake Powell will release 9 million acre feet. They were supposed to release 11, but the March was kind of a little dry, but this 9 million should be enough to keep Lake Mead from descending below levels that will again trigger a shortage declaration. But I think this is sort of for them like almost 16 years of drought. But simultaneously, extreme rainfall events have been increasing in the United States, especially in the Midwest and the Northeast. And this is a diagram that we put together for the congressionally mandated U.S. National Climate Assessment. And it's showing the changes in percentage in the extreme rainfall events. So these are not the gentle rains from heaven that you want for your crops. These are incredibly erosive rains. So these are the rains that would normally be in the 1% most wet, and they have increased 45 or 74% in the Midwest and the Northeast. So it's making these kind of events much more current. So this is a flash flood in Europe in August of last year, which caused $6 billion. Much of that not insured and killed some people. But we also saw this in Ames, Iowa. They got 5 inches of rain in one night. And I'm sure you heard about Baton Rouge also in August. 20 inches of rain in 3 days, and the cost of Baton Rouge, $10 billion, 75% of that insured, but 13 people's lives lost. You're also increasing the forest fire season on the bottom from what used to be 5 months to 7 months, but also the number of very large wildfires are going up. So again, this combination of heat, drying, pest outbreaks can lead to incredible fires. And if you look globally over time, insurance companies are worried. And this is a chart from Munich Re. So ignore the red part on the bottom because that's earthquakes, things that are not related to climate. But the other extreme events, green is meteorological, blue is hydrological, and yellow is climatological. You can see how those used to hover at about 400 in the 80s, about 600 in the 90s, and now are hovering at more than 800. And in fact, last year there were 900 of these events. And this is how they were distributed. And so you can see, remember, it's yellow, green, and blue that are a problem. You know, no part of the world is excused from these. These are very big, very expensive events. And so some of the impacts of climate change, like heat, are now being statistically clearly linked. You know, it's been the common mantra of scientists was to say you can't link any event to climate change. But in the case of heat, there actually is some pretty good information. And so I'm sure that all of you know what a normal distribution is. This is the typical curve, and these are summers in 1950 to 1980. So a third of them were cooler, that's the blue part, a third of them were average, that's the white part, and a third of them were hot, so that's the red part. But between 1980 and 1990, we see this shift. The next decade, we see this shift. And so now, things that are way over on the right in 3, 4, and 5 sigmas, or standard deviations, that would be virtually impossible, are becoming much more common. And so the extremely warm summers that would only cover a tenth of the land area now cover 10%. And so it's the power of some of these data that have been able to link, especially heat, and in some cases maybe drought as well, to being impossible, to be unprecedented, and without climate change. So these are the changes we've seen already. What does the future portend? Well, it really depends on what happens on the mitigation side. And so Paris Agreement, the countries that came together agreed to do what's above that middle arrow there, and that would not keep temperatures at 2 degrees C, which is the agreed upon number that we want to get to, but they would have us between the roasted world and the non-roasted world that I showed you in the beginning. This is where we want to be. And as you see, whether we're talking about food, water, or ecosystems, the higher the temperatures go, the redder the arrows and the more problematic it becomes. And so already at 2 degrees, we have to worry about coral reefs, for example. But you can see how hunger and water scarcity and other issues become much greater as you move up that temperature track. And I actually talk about that and then show my students this chart, because most of them are graduating in this time frame. And what I'm showing you here is how the US number of days over 95 degrees might change over their lifetime. So you can put your children or your grandchildren or yourself in this as it makes sense. But you can see that by the time they're old, you're approaching 175 days over 95 degrees in parts of Texas and, unfortunately, parts of the Southwest. And I think this, kind of gives you a very clear image of how the world will be very, very different. There's lots of information in the peer-reviewed literature about how heat waves are expected to increase. These are just a few of the articles. But one of the things that I think is so interesting, I showed you in 2003 how anomalous that Europe heat wave was. But if you go forward in time, that's going to be the normal summer by 2040. And by 2060, that's a cool summer. So again, it emphasizes just how dramatic these changes are. This next chart shows you on the left the plant shifts that have already happened in colors, but by the next 30 years, these bands of plants will shift. So it's kind of like a tier of states worth of plant hardiness zones. The hardiness zones are the coldest temperatures that a plant can endure. So we're kind of excited in Michigan that we're getting we can grow all kinds of different things. I mean, you can actually grow dogwoods in Nebraska now, and that you're seeing that plants are shifting in response to the pressure of the temperatures. Plants are either moving latitudinally towards the poles, as it's showing here, or altitudinally up mountains. And some models suggest that a plant would have to move 45 feet a day, or up to 300 miles, to keep up with this shifting climate. Well, of course, that's not going to happen. And so we're going to lose some species, or we might have to think about aided adaptation, or being Johnny Appleseeds to keep up with this shifting climate. We're already seeing maple trees simply head off into Canada. When I showed this chart for the first time to the landscape architects in our school, they completely freaked out, and they said, we tell everybody to plant native, but what's native if it's marching up the states like that? And actually, the city of Ann Arbor is now planting trees that have more plasticity, as it were, that can withstand the expected temperature changes over the next decades that we hope those trees will survive. And interestingly, businesses are beginning to worry about their global supply chains and whether they can get what they need when they need it, given the increased number of disasters. And I don't know, I hope you might recognize this photo. That's the Seaside Heights, New Jersey, after Hurricane Sandy. And this called Risky Business was put together by Hank Paulson, Tom Steyer, and Michael Bloomberg. And they said, you know, there is so much infrastructure at risk as sea level rises. By 2050, up to 106 billion worth of property could be underwater because of sea level rise. And by 2100, it could be $1 trillion. And Florida and Louisiana's coasts are in for most damage because a lot of that infrastructure, like Mar-a-Lago, is built at very low elevations. But, you know, we may be able to cope with this level of sea level, but this is what it would look like in Vietnam. And this is 9 million people who would be displaced by 3 feet of sea level rise over the century. And we expect that the sea level rise will mean a lot more environmental refugees. So here I'm showing you cities in the dots that are more than 1 million people, and a 3-foot sea level rise would be devastating, putting infrastructure and people at risk there. And so scientists are beginning to get very worried that we may be, if you will, traversing some planetary boundaries and hitting some tipping points by pushing the climate so fast and so much. And some of these that you see here include the potential for massive forest die-off in the Amazon, or boreal forests, or monsoon shifts, or the melting of both Greenland and at least West Antarctica. And some of these are essentially irreversible. Shifting rainforest to savanna to desert would be essentially irreversible. Or the dying off of the coral reefs, as is happening now in the Great Barrier Reef in Australia. And then there are also what I would call fragility hotspots. I mean, these are places where poverty and climate change and unstable government and disaster risk could all combine to create really national security issues. And I think it's probably no secret to you that the Department of Defense in the United States really takes potential climate change and conflict over water and food and loss of homelands very, very seriously. So can we avoid these tipping points? Well, here, now I'm just showing you the last 20,000 years as we popped out of the last ice age. Let's say the Paris Agreement works and we manage to stay in that green range, which we want, which is the 2-degree world. And there are a bunch of scenarios there on the right of where emissions could be, but let's say we're gonna do it in Paris. Well, Paris, 2 degrees, would still put at risk these tipping points: the West Antarctic ice sheet, Greenland, Arctic summer sea ice, alpine glaciers, and coral reefs. And so this is another way of me showing you that burning ember chart where the red arrows are getting redder and redder. So if we are successful, we still have those potential tipping points. Okay, wither the climate agreement. I left the H in. Here we are. all very excited. The world celebrated the Paris Climate Agreement. It's not enough. I showed you it's between the two worlds, the roasted and the non-roasted, but it was a bottom-up effort, and countries agreed to what they could agree to. They promised what they wanted to. It's been 22 years in the making. It kind of tracked the development of the science in this delicate dance of diplomacy, science, and so here we are today. And here's Kerry signing this on Earth Day last year with his granddaughter, because it's about her generation. And it actually came into agreement on November 4th, before the election, and when you needed 55 countries and 55% of emissions, and they had more than that, 86 countries and 62% of emissions. And since then, we have 194 parties, all the gold ones have signed. Actually, everybody that's a color signed, and the blue ones are the ones who have actually ratified. So this is an amazing agreement. If you think back to Kyoto, you know, we were basically a few countries of the world making a first step on emissions. So that's pretty impressive. However, agreements are only the beginning. So what does the Paris Agreement do? Well, if we have these intended nationally determined commitments, so this is what the countries promised, versus if we don't do anything, by 2030, we've made a teeny little down payment. And so the really important thing is to keep up ambition and to keep going. And so some of the estimates suggest if you only do what people have promised now and kind of keep up that current level of ambition, you get nowhere near the pink bar, the 2-degree bar. You really need to almost double the ambition every few years. And so it's a very dramatic difference that's needed. But this argues that you need to keep everybody in, and you need to keep everybody's feet to the fire. There are some very good things about the Paris Agreement. So it absolutely talks about controlling emissions and getting them at least to 2 degrees, if not lower. So it has a very serious goal that can keep you from that non-roasted world. It has increasing ambition over time. It calls for transparency, so countries doing what they said they were going to do and ways to monitor it. And it also talks about increasing public and private research and development money, about equity and funding for the poorest countries for both mitigation and adaptation. And then there are agreements by mayors and companies and pledges by hundreds of groups. And I guess I just want to say that I think we've actually reached a tipping point in the momentum and in public opinion to act on Congress. So we have had, for a long time, the very strong drumbeat of science. But we are beginning to feel climate change impacts. It's costing billions of dollars. Some new voices are appearing that are calling for action. Renewables are dropping in price precipitously. We're seeing cities and states and countries taking action. Businesses are responding. Dozens, if not hundreds, of campuses are acting, thousands of cities. And we actually had a conference of parties, COP21, where 194 countries all said, yes, we have to do this. And I think 194 countries, the US is just not that important anymore. And I think it will go forward with or without us. This is a very new poll. It actually says the number of people in the US who think global warming is happening, every county, even conservative counties, more than 50%. And you all are coming in at a much higher rate, at around 70%. So people actually believe it's happening. There have been many interesting new voices on climate change. The World Bank says, Jim Kim, the president, I cannot achieve the goal of reducing poverty without confronting climate change. And then we have the Dalai Lama, and we have the Pope and the fabulous encyclical. And in fact, at Paris, 154 religious leaders said we have to act on climate change. So we're having new voices that are very powerful voices. In the area of renewables, in 2015, renewables surpassed coal to become the largest source of global electricity capacity. That doesn't mean it's generating it now, but the capacity is in place. And I think that's a very important point. 7,100 cities, that represents 600 million people, are signing on the Compact of Mayors for Climate and Energy. 1,000 business leaders wrote to President Trump, and they signed the Business Backs Low Carbon USA statement. That's all happened since the election. This one, interesting to watch in the Congress. The membership of this bipartisan climate solutions caucus has doubled. The rule of joining this is a Democrat joins, you bring a Republican, or a Republican joins, you bring a Democrat. They're calling it kind of the Noah's Ark, so you got to bring one of each. But there's 36 of them, and they actually meet almost every 2 weeks and talk about climate solutions. That's in our Congress. 50 countries have vowed to use 100% renewable energy by 2050. And here are 83 major companies that similarly are saying they're going to go to 100% renewable. So I really do think that the issue of climate change and the consensus that we have to do something about it, and that there are ways to make money acting on it, and there are ways to lose money by not acting on it, has hit an important point. So I want to end by saying that I think, we are at this tipping point, and that we can, because of the interest in attacking climate change, avert a planetary tipping point. And I think more than ever, we are more responsible for our own future than any other generation has been. And I simply refuse to believe that our generation will be the first one to leave the next a truly irreversible problem. So thank you very much. That's great. I think this whole idea of sort of a circular economy where it's use and reuse and not waste is also gaining a lot of attention. And, the making of things is what uses up an awful lot of the energy that we're producing or we're using. And so I think using sustainably harvested woods and recyclable things is a very important thing. So thank you for that. Yeah, and as you know, President Obama had a social cost of carbon that all the agencies are trying to use, although I think that's being undone even as we speak. But most businesses many businesses are actually incorporating a social cost of carbon and thinking about that as they calculate their bottom line. And more shareholders are asking them to disclose their risk because of climate change. And so I think that's very important. I think if you have a price signal on something that's bad, people will come up with all kinds of creative ways to reduce that bad. And I guess my hope is that if we actually do comprehensive tax reform, there might be a way that, as you say, with this caucus, that members of Congress might be willing to have some kind of tax reform if there could also be something like a carbon or an energy tax. And I think now that's almost the only way it could happen, is if you do it within that monster tax reform. It's been interesting to watch the debate over the budget. We saw that the science budgets are actually up for 2017. Margaret and I were talking about this right before. I think this caucus and others are trying to satisfy their constituents, and Lord knows you can talk to your constituent much more easily than I ever could, even when I worked for the Congress. So please make your voices heard. Oh, the question was nuclear power. Can it work? And cooling water, and what's the role, I guess, is in the broader situation. So what I didn't show you was the various ways that models assume you could reduce the CO2 emissions with different technologies. And almost all of them that can still get to 2 degrees, and it's really, really hard, require nuclear to be in there. And so because in the US it's 19%, where are we going to get that from? And you would have to really, really, really ramp up many of the other things, including carbon capture sequestration, second generation renewables, et cetera. So I think there could be a role for nuclear. It's not my favorite technology, but I think if there were ways to solve the problems of proliferation, safety, and waste, those 3 big problems, and that at least those I know who study this far more carefully than I do think that there could be a role for smaller, more modular nuclear power plants, that were almost kind of cookie cutter as opposed to one-offs. And that investing in figuring out if there's a future for it is certainly necessary, because we kind of need all technologies that we can get as fast as possible. So most models assume nuclear continues to play a role and actually grows somewhere from slightly to a lot, depending on which model. So the question is, what do I think about the news that came out today about removing scientists from advisory panels and replacing them with folks from industry? And so far I've only seen it for the Environmental Protection Agency, but that's really, really important. And by tonight, one of my fellow Michigan faculty has something up on Huffington Post why this is wrong. I mean, you really need, you do need a mix of people involved, and you need stakeholders involved, but science advice on regulatory policy is a very particular role. I mean, I think you want to understand what the science says about the problem you're trying to address, and demarcate sort of that area within which you should act. And so when we did the ozone standards, for example, with Carol Browner, who was very, very green, my job was just to say, look, the science studies say you got to be between here and here. The decision is a political one, but the science says if you want to protect people. So it seems to me, I mean, not that industry scientists are all bad, but it seems that if somebody has a vested interest in not regulating something, being pure about the box that science puts you in is a lot harder to reflect. And so when we did the Montreal Protocol and ozone protection, industry people were actually extraordinarily helpful, because they said how fast and where we could go to reduce emissions in the international arena. So, but I think it's very bad to be removing scientists who are academics one by one by one. And I think that the March for Science that so many of us took part in many places, and I know Ralph spoke at the one here, are very, very important. I mean, I started by saying that I really commend, Dave Keeling for being a principled scientist, and that's what I think we have to argue for, is principled science, not science in the interest of economics.